Africa is currently experiencing a profound and dramatic transformation, a geological process so extraordinary that it is actively reshaping the very structure of the continent. The immense expanse of the Earth's crust, situated beneath East Africa, is fracturing and breaking apart, an event that is slowly tearing one of the largest single landmasses on the entire planet into separate pieces. This monumental activity involves the Somali and Nubian tectonic plates gradually pulling away from each other, a movement that is causing a massive rift to expand at an almost imperceptibly slow rate, and this very process is ultimately giving way to the creation of an entirely new ocean that would dramatically change the world along with it. In this detailed video, we are going to bring you all the critical information about what is actually going on beneath our feet, and we will explore if there is any conceivable way that we would successfully come out of this global geological event in one single piece. A significant event that triggered global awareness was the 2005 Dabahu eruption. The intense seismic activity leading directly up to the monumental 2005 Dabahu eruption was nothing short of truly extraordinary. Back in September of that particular year, the remote Dabahu area, which is situated directly along the geologically active Afar Depression in Ethiopia, began experiencing a rapid and frightening cascade of earthquakes, with over 130 individual tremors being recorded within just a single week. These persistent tremors were not minor or insignificant events. They were powerfully measurable and served as strong precursors to a major unfolding geological phenomenon. The local communities living in this extremely remote area were both deeply alarmed and utterly bewildered by the shocking intensity and unnerving frequency of the quakes, which caused the very ground to rumble almost continuously. For the local residents who had absolutely no prior warning or scientific context, it seemed as though the seemingly stable ground beneath their feet had turned volatile and dangerous overnight. Each distinct quake was a clear signal, a momentary burst of immense energy being released as the Earth's crust violently pulled itself apart. Deep beneath the surface, the massive tectonic plates were tearing away from one another, and superheated magma was surging upward into the numerous fissures being created by their ongoing separation. The international scientific community quickly took serious notice as sensitive instruments recorded this rare alignment of seismic and tectonic events, and an unprecedented continental rifting process was decisively set into motion. While relatively small earthquakes are somewhat common in tectonically active zones, such a concentrated and powerful sequence pointed unequivocally to a much larger event brewing deep underground. On September 26, 2005, the Dabahu volcano itself erupted catastrophically. Magma forcefully pushed its way to the surface with violent force, violently ejecting thick ash, molten rock, and dangerous gases high into the atmosphere. While the eruption was not considered particularly explosive by global volcanic standards, its sheer geological significance was absolutely unmatched. The powerful event caused massive fissures to open up, deep cracks that split the very earth in ways that were clearly visible to the naked eye. As a direct and devastating result of this intense activity, approximately 6,300 local people were forcibly forced to flee their homes, desperately seeking shelter as far away as possible from the now unstable and dangerous land. Entire families were tragically displaced, and communities wholly reliant on subsistence agriculture were thrown into complete chaos as vital livestock was destroyed in significant numbers because of the sudden geological upheaval. The catastrophic loss of precious livestock only exacerbated the severe human impact of this terrible disaster. The displaced communities faced immense challenges in the immediate aftermath. Critical food insecurity became an immediate and pressing concern, as did reliable access to clean drinking water. Organized relief efforts struggled to reach some of the most severely affected areas, further showing us the profound vulnerability of those living in the harsh Afar Depression. Yet amid all this terrible human suffering, a global community of dedicated geologists and seismologists had their eyes fixed intently on what the volatile region was revealing about the Earth's inner workings. What made the 2005 Dabahu eruption more than just a devastating regional disaster was the incredible scale of geological transformation it powerfully triggered. In the tense days immediately following the initial eruption, An astonishing 37 miles of deep fissures opened up across the Earth's surface, dramatically stretching the landscape like a fresh wound, tearing ever deeper. These extensive fissures weren't just shallow surface cracks. They extended dozens of feet deep, revealing glowing molten rock and intense thermal activity. The Earth itself, in real time, was ripping itself apart, actively forming a massive rift that would continue to expand for millennia. The displacement of the ground was simply unbelievable, with entire sections moving several meters within mere days. Detailed satellite imagery and careful ground observations showed these dramatic shifts in terrain that seemed almost surreal to those scientists witnessing it. For the scientific community, it was a vivid and unprecedented example of plate tectonics, the massive yet typically invisible forces of the Earth in direct and observable action. The intense rifting was driven by the powerful divergence of the Somali Plate and the Nubian Plate, two massive tectonic boundaries under incredible tension. As these two plates slowly drifted apart, the thin crust overlying them fractured dramatically, creating perfect pathways for magma to rise directly to the surface. The Dabahu eruption became a rare and invaluable opportunity to observe continental rifting on a human timescale. Unlike most tectonic processes that take millions of years to become evident, the intense activity at Dabahu unfolded over mere days, weeks, and months, allowing scientists to document and analyze each step of the complex process with unprecedented precision. Networks of GPS sensors and sophisticated seismic equipment captured invaluable data, showing that the 37 miles of fissures represented just the initial stage of a future ocean-forming rift. The Afar region was, essentially, laying the natural groundwork for the eventual creation of a new sea. These critical findings shed light not only on the specific tectonic processes governing the immediate area, but also on similar events that might have occurred millions of years ago during the splitting of ancient landmasses like Pangaea. This modern-day rifting provided a unique time-lapse view of Earth's evolutionary processes, offering critical insights into how major landmasses fragment and vast oceans form. The Dabahu event clearly illustrated that Africa's ongoing rifting wasn't merely theoretical or anecdotal, but a vivid, undeniable fact. It demonstrated convincingly how the Somali and Nubian plates, previously considered relatively locked, could actively tear apart with enough accumulated tectonic stress. Magma, ceaselessly surging from below, acted as a powerful force multiplier, aggressively pushing the plates even further apart. For researchers, this perfect alignment of forces was a textbook case study for understanding the fundamental mechanics of plate tectonics. While the 2005 Dabahu eruption marked a decisive turning point in scientific awareness, it was just the very beginning. Subsequent detailed studies and ongoing tectonic activity have revealed even more about how this relentless rifting process will continue to shape the continent and its people in the coming many millennia. But what actually makes the Afar Depression so uniquely special, and why does this particular region seem destined to completely transform Africa's fundamental geography? Understanding the East African Rift is key. The East African Rift is one of Earth's most striking and significant geological features, stretching roughly 3,000 kilometers from the Afar Depression in the north of Ethiopia down through Kenya, Tanzania, and further into Mozambique. This vast and active rift system marks the clear boundary between two major tectonic plates, the Somali Plate, which is slowly drifting southeast, and the Nubian Plate, which is steadily moving northwest. It isn't just a simple line on a map. The rift is a dynamic evolving feature where the Earth's crust is actively breaking apart. This immense process began millions of years ago and continues to unfold right before our eyes. Scientists often describe this massive zone as the most profound example of active continental rifting on the entire planet. What makes the East African Rift particularly unique is that it's not just splitting the African continent in two. It's also creating entirely new geological structures like deep valleys, extensive fissures, and even future coastlines. Unlike the relatively slow tectonic shifts happening in many other parts of the world, this specific rift is active enough to be observed and measured in human time frames. Understanding how the rift works reveals the forces at play. The East African rift owes its intense activity to one key driver: magma. Below the Earth's surface, magma wells up from the hot mantle, intruding into the developing rift and creating immense pressure that forcefully pushes the Somali and Nubian plates apart. As these two plates continue to drift away from one another, the crust in the rift zone becomes progressively thinner and more fragile, continuously forming new fissures and fault lines. Magma intrusion is a core mechanism of this entire process, as molten rock finds its way into these open fissures, cooling and hardening over time to form brand new crust. Over millions of years, this creates a continuous cycle of destruction and renewal. Older crust is broken apart while new crust is added in its place. The East African rift is, in effect, a massive conveyor belt for new land formation, a phenomenon more commonly seen at mid-ocean ridges deep under the sea. But the powerful forces shaping the East African rift extend far beyond just magma. Gravity also plays a key and vital role. As the rift expands, massive sections of the Earth's crust sink under their own immense weight, forming dramatic escarpments and extremely deep valleys. These valleys often fill with water over time, as clearly seen in the region's iconic Great Lakes like Lake Tanganyika and Lake Malawi, which neatly trace the rift's southern trajectory. In total, this ongoing geological activity has already created one of the most geologically diverse landscapes on Earth, filled with active volcanic peaks, bubbling hot springs, and exceptionally fertile soil. Over immense spans of time, the relentless forces pulling the Somali and Nubian plates apart will widen the rift to the point where ocean water begins flooding the area, likely from the nearby Red Sea and the Indian Ocean. When this eventually happens, Africa will physically split, and a new ocean basin will form between the eastern horn and the main body of the continent. This isn't mere speculation. It's an inevitability dictated by the fundamental principles of plate tectonics. Similar processes have happened before, most notably during the breakup of the ancient supercontinent Pangaea. Around 180 million years ago, the Atlantic Ocean began to form when tectonic plates tore apart the landmasses that would eventually become Africa and South America. Today's East African rift is a smaller-scale version of that ancient process, but the end result will be no less dramatic for our planet. Though the full creation of this new ocean will take tens of millions of years, current geological activity shows we are witnessing its very earliest stages. Some segments of the rift already dip below sea level, particularly in the low-lying Afar Depression, where continuous magma-induced subsidence keeps lowering the land. Precise satellite observations have shown that the rift is widening at an average rate of a few millimeters per year. Over geological timescales, this steady and relentless movement will result in the rift becoming completely unrecognizable from what it is today. When the ocean finally forms, it will not only change the physical geography of Africa, but will also reshape the global map itself. Future generations may recognize a continent split into two distinct regions, with new coastlines bracketing the newly formed ocean. The formation of a new ocean will dramatically alter the climate, ecosystems, and biodiversity of the entire region. New coastal areas will emerge where none previously existed, leading to new opportunities for unique marine habitats. However, this profound transformation will also pose significant challenges for human populations, particularly those reliant on the land for agriculture and livelihood. In places like the Afar Depression, where fertile valleys and lakes provide critical sustenance for local communities, the flooding caused by ocean encroachment will likely displace hundreds of thousands of people. Volcanic activity associated with the rift could also intensify, as magma continues to rise and erupt, potentially threatening nearby populations. Moreover, the changing geology may influence local climates by affecting wind patterns, rainfall distribution, and access to precious freshwater resources. The East African rift serves as a vivid example of tectonic forces reshaping our world. Yet the ongoing changes in this vast region are part of a larger, more intricate geological narrative, one that hinges on the unique characteristics of the Afar Depression, the undeniable epicenter of all this rifting activity, the engine behind. The rift involves the dynamics of the rift system itself. At the very heart of the East African rift's dramatic transformation